no TIDA. You prepare the similar report, because report has to be sent by you.
Sure, sir. I will do that. I have. Yeah, sir. Satish sir has.
Oh, are you surviving? Great Satish sir, you are still big principal, vice principal. When you are becoming principal, you see, I look much younger than you. You people are without beard, without this. What is this? What is your life? You do not know how to treat your life. This is, see Chakravarti. He can marry once again. See him. How are you?
Unmute,
How are
sir.
you?
Chaudhary,
How is
sir.
New Year will treat you?
Yeah,
How
I'm
you
fine.
treating New Year?
No New Year celebration, sir.
No, but going. Only make Italy and what dosa.
all regular, sir.
Yes. You should visit, both of you should visit Bhubaneswar once.
Yeah, definitely, sir, definitely.
I was telling Chakravarti, make me a research advisor. I'll give 50 journal paper. 50.
Okay. Thank you, sir.
50 journal paper. Guaranteed. Output is guaranteed. 5 research project. I'll be co-investigator. I'll give guaranteed, but pay money. The institute has to pay money. Advisor charge.
Sure, sir.
You tell your sir that Panda sir wants to boost R&D.
Sure.
And
if visible output.
Yeah,
I believe
sure, sir, definitely.
This C.V. Raman has 50 journal paper last 1 year.
Oh, great.
50.
Oh.
They are paying well. So I'm coming.
You are there, sir. You are boosting them.
I advise this one, Jain University, Triple IT, varieties of place. But you people are not able to exploit. Tell him, energize him. Really, from everybody's mind, I will take it out, all papers. So many papers.
Definitely, sir.
Sir is asking to send Suresh and Anil to his place.
Always you people are loaded with tension. I am tension free.
Yes. So definitely, sir, we will send our scholars to you and your place. Definitely, we need your support in making our scholars to publish good papers.
Yes.
And there are few scholars who are working under
you start as an example. Space. You do 2 transactions, he does transaction. I will help. Your they can come here, they work here, I will put them free stay here in a hostel. They have my lab, they will work here.
Sure, sir.
Every day, morning 6 o'clock to night 10 o'clock.
Sure, sir.
Good. I have gone to different phases. Now I teach IoT, security, machine learning, deep learning. Now signal processing has become next, but signal processing is still there. But distributed signal processing, new type, robust signal processing, intelligent signal. The ordinary signal processing, you have to adjust and change.
Yes.
Yeah.
Good. I was very happy. I told Chakravarti I want to see Satish, the vice principal, so that I feel elevated to teach.
Little busy with this academic structures and other issues, sir. Here, counseling is yet to start today.
Okay.
From state government. So there are certain issues that have to be finalized from our side.
Okay. How is your admission this year?
Sir, admissions not yet started, sir. Today only they are starting, sir.
Okay.
We will get the information by Sunday evening or Monday, allotment of seats and everything.
Good. Very good.
Yeah. Okay, sir, shall we start?
Yeah,
Yes.
please carry on.
I'll
Okay.
start.
Okay, okay. Thank you. Thank you. We have all the students and faculty joined, sir. Some of them have joined through YouTube. They are going through the live streaming on YouTube.
Yeah, deep learning. Are you able to see the slides? Are you able
Yes,
to
sir. Yes, sir.
visualize?
Yes, sir.
Yes. Okay.
Yeah.
If I
Yes.
change, it will change here or here.
Yeah, it is
Is it
changing.
visible?
Yes, sir.
Visible, sir.
It
Visible.
is visible. So, all the participants, third and final year, and members of student branch of Institute of Technology, of Raghu Institute of Technology from various disciplines and departments, and all HODs and all Raghu Institute of Technology. I warm welcome you all once again for the second day of Distinguished Visiting Professorship program lectures by Professor Ganapati. Today, as promised yesterday, we'll be dealing CNN and deep learning. And tomorrow, the biological neural network, spiking neuron, and some examples on it. So, a lot of research problems will be dealt and addressed during the sessions here. So, I request everybody to make use of it. Kindly note down any problems that you come across, you feel like queries that you have to be taken to the notice of Panda sir and get addressed by him. So them quickly in the chat window or directly to me in our WhatsApp group so that I can put forward for Panda sir. Be dealing it at the end of the session. Okay, thank you, sir. Thank you once again for your valuable contribution yesterday, today, and tomorrow. Uh, I welcome you on behalf of the management of technology, principal, vice principal of the college, and all the staff members and students of Department of ECE. Welcome you once again for the second day of much eager.
Yeah. Start now.
Yes, sir.
Yeah. So, let's. Yeah, the slide is visible. Is it okay?
Yes, sir. Visible
Yes.
and okay, sir.
Let's start. Yes. So, good morning to all of you. I'm with Professor Panda again, starting to deep learning methods. The first one, I'll be covering the fundamentals of deep learning. It will take about 45 minutes or 40 minutes. I'll give a break of 5 minutes, and then I'll go for one type of deep learning, that is convolution neural network, CNN. And after that, I'll give a gap of couple of minutes, and then I'll start another one, maybe autoencoder or LSTM or RNN, depending upon the availability of time. So why people are so crazy about deep learning? People are crazy about deep learning. Now, what is actually the meaning of deep? So, just slides and okay. So this is the outline of my talk. Am I visible?
Sir, visible, sir. The
Slides are visible. But
yes,
am
sir.
I visible?
Slides are visible. You are not visible.
Okay. But okay, I can teach like that. So I'm not visible. It's okay.
You are audible.
Okay, this is the outline of my talk today. Basically, I will tell about what is deep learning, what is deep inside, so that you can able to carry out some work in the deep learning area. So basically, once I know it is what is deep, basically there are many layers. Many layers are there. In human being, as I was telling yesterday, the brain consists of more than 100 layers. So today, many of the problems having large data size also requires 100 or even more than 100 layers. Now, the most fundamental types of deep learning are convolution neural network, recurrent neural network. And these networks have a lot of potential application. I will tell maybe tomorrow some of the potential application. Please see, machine learning. Inherently, deep learning is a type of machine learning. Deep learning has some special features that I will tell. But machine learning today, why it is so important? Why machine learning? It is not only computer science, electrical engineering, or electronics and communication engineering. Today, all branches of engineering, even economics, management, extensively use these types of learning. Basically, see, the data is given. Everywhere we collect data, large amount of data. Where from data comes? Data comes from measurement, from instrument, from experiments, from communication channel, and all these sources of data, we call it time series data because they are measured across various time interval. This data is essential. These are called raw data. The second thing that we want to use some algorithm today to become a successful professional or professor or researcher, you have to learn about minimum 60 types of machine learning techniques. Today, the machine learning techniques are 80 to 85. At least 60 you have to learn. These consist of two parts, statistical machine learning and intelligent machine learning. For example, your support vector machine, naive Bayes, random forest, decision tree are example of machine learning techniques. Also, you can call it backpropagation, fuzzy logic. They are also set of machine learning. Now, these algorithms are used for what? They take the data, they train a model. Train a model. What is a model? Model can be an artificial neural network, it can be a support vector machine, it can be a neurophagy network, it can be a decision tree. So there is there is a wiring diagram, there is an architecture. Therefore, these types of models has to be first decide which architecture we have to take. This second one is more important, that the algorithm will train the model using the data backbone. Using the model is trained with the help of a learning algorithm, like backpropagation, like your CNN has a learning algorithm. So learning algorithm, like LMS or RLS, train the parameter of the model. Once the model is trained, then the model is ready for performing some tasks, like what are the types of tasks? Prediction, classification, clustering, detection, inverse modeling, direct modeling, etc. Now, the model can be trained by two ways. The model can be trained by two ways. First way is supervised learning. The second way of training is unsupervised learning. I'll clarify this thing. I give an example all the time that if you're learning a cycling, you're learning how to cycle, how to drive a car, how to cook. You do not take the help of anybody to train. And in case of unsupervised learning, nobody trains. In case of supervised learning, teachers trains, the parents train. So your deep learning also has two types: supervised deep learning method, unsupervised deep learning method. And please remember, there are two phases of operation in supervised learning. One is training. One is the training phase. Usually 80% of the data are used. Usually 80% of the data are used for training purpose. Sometimes it is 70. And remaining 20% or 30% are used for testing or validation. There are another type of training known as K-fold training. K-fold training. What is K-fold training? It's a threefold training. Means two parts. The data is random, three parts. Two parts are randomly selected. These two parts are used for training, and the remaining one part are used for testing. The other types of training is fixed 80 part and 20 part. This I will explain whenever the situation occurs. Please see, I told there are another types of learning. These types of learning is called reinforcement learning. What is reinforcement learning? You keep a building with 10 rooms, put food in one of the room, get to search for food, and you will be astonished. After some time, the cat go to the food source. How the cat learns, and that is equal to your reinforcement learning. Today, reinforcement learning finds a lot of potential applications. If you want, and Professor Chakravarti allows, tomorrow I can teach and learning. Okay.
Yes, sir. Yes, sir.
Yes. So
Yes.
basically, reinforcement learning, I request Professor Chakravarti can use for his research work in antenna. Very, very interesting. The basic task of reinforcement learning is clustering. You are doing the grouping without any supervised learning algorithm. Regression prediction or classification are mostly supervised learning. So what I essentially tell, supervised learning are algorithms in which you need to know the desired output. You have to know the target output. You have to know your specified output, what it should be from the past. Example, $1 is here, everyday data is plus, or $1 is how these are old data. So knowing the old data, we can predict healthcare. We know 100 cases of patient. Under what test condition the person is disease person or non-cancerous. These are old data, test data. Using this, you develop a model, and that model is used to predict for an unknown patient. You bring a patient, make some test, put to the model. The model will say whether that particular person is having cancer or no cancer, having COVID or no COVID. Recently, we have sent a good paper from speech data. Yes, how to find a person is having COVID or not COVID. So, a lot of work can be done on healthcare in many of the applications, manufacturing, healthcare, finance, you can use. But supervised learning is very, very simple. But question is unsupervised learning. Your clustering is an example. You are able to group them without anything. Your unsupervised learning has a lot of potential application. You must learn. At least there are about 10 to 12 types of unsupervised learning. At least couple of them you must learn and practice. Coming to the reinforcement learning, as I told, that it is you create an agent, you train the agent guides you to train the model. The agent does a work to the model, more reward or less reward. So depending upon the reward, adjust yourself. So this is a very, very interesting thing. Maybe tomorrow, if you want, I can teach. Now, what is the essential difference between machine and deep learning? As you know, machine learning do not take raw data. Machine learning do not take directly the data. If the data is directly taken, then the training is more time taking. The accuracy is less. Third thing, the complexity of the hardware is more. Therefore, people are extracting the features. From the data, 3 types of features are extracted. Please remember, from the data, 3 types of features are extracted. One is statistical feature, mean value, variance value, higher order moments, kurtosis are called statistical feature. Similarly, the other types of feature are transform domain feature. From input data set, you take Fourier transform. The Fourier transform value become the features. Take wavelet transform. Take smartlet transform. So the transform domain values are used. The transform domain values are used as features. The third type of features that we extract is called technical feature. For stock market prediction, technical feature is different. For antenna research, the technical features are different. So for robots application, the technical features are different. That depends on the types of problem. When you have three types of features and the features are mixed, then the amount of feature becomes more. When lot of features by three types, the features need to be selected. So feature selection, feature reduction, feature reduction. How to reduce? There are techniques where the features can be reduced. There are techniques where the feature can be selected. We must know that feature selection. This is the conventional, but thanks to deep learning doesn't about features. What about the types of required features? That the method extracts the types of feature that is needed, and the first layers, the first layers of the architecture are dedicated for feature extraction. Let me tell, in case of convolution neural network, in case of CNN, the convolution operation extracts the feature. Remember. So there are many types of ways the features are extracted. You need not have to bother which feature is good, which feature is bad. And therefore today, the deep learning has become very, very important. Am I clear? Machine learning from the data extract the feature. Features are used to the model for training. But remember, in case of deep learning, no features extraction are required. Please have a look to this drawing. First, say the first one diagram. A car is there. From the input data, we are extracting the features. Feature extraction are of three types, I told. People are using only one types of feature, or maybe second two types of feature, but not all types of feature. Now the features are put to the classification model. It can be artificial neural network, zero fuzzy network, support vector machine, any types of architecture. And that will generate, output will tell it is a car or a truck or a bus. So it is a classification problem. In case of deep learning, see the number of hidden layers are more. I have shown 2 hidden layers, but it can be much more. And the input is the image. Directly, the image data is put to the model. Once the data passes to the model, the output of the model is classification, whether it is a car or no car. Essentially, the botheration of feature extraction is not there in case of deep learning. Deep learning, by first few number of layers, the features are extracted. For example, in case of CNN, the convolution operation extract the features. Yes, so this is the deep learning is superior to conventional machine learning. If you look to this, until there are 2 things, at least in the last 1 decade, deep learning after 2010 has outperformed the conventional machine learning methods. Before 2010, nobody was bothering, but the machine learning still remains as green but people are preferring deep learning. The second situation in which deep learning is to be used is what? Is data size should be large. For smaller the data size, it should go for a machine learning technique. But if your data size is more, you should go for deep learning techniques. I think I'm clear. Now, little bit information, artificial neural network. Artificial neural network, as you know, is massively distributed, interconnected system. As I told yesterday also, there are how many inputs here? There are how many inputs here? 3 inputs. Hidden layer how many? 4. How many out? 2. So in essentially, there are how many connecting weight? 6, 3 into 4, 12 to 8. So that is, and number of bias weights are hidden layer and at output layer. That is 4 plus 2, 6 biases. And output is computed weight matrix multiplied with the input vector. You produce a vector, add the bias vector, pass through sigma, which is activation function. Activation function, various types. People use ReLU function, people use sigmoid function, people use 10 hyperbolic function, people use different types of sub. So every function has their own limitation and own advantage. So these are the types of activation function which are used in deep learning. Deep learning, particularly in CNN, people use 10 hyperbolic function as well as also softmax function. If you look to the training, yes, training, you are giving the input data. You pass through the network in a forward manner. That is, input is multiplied with weights, sum them, put the bias value, pass through sigmoid function, get the output. This becomes the output of one neuron. Same thing happens for other neurons. And the output of the first set of hidden layer is passed to the second layer. Same operation takes place. Exactly the repetition. And in this way, you produce the final output. The final output is compared, because it is supervised learning, you get an output. The output of the model and the desired input are compared. You get an error, and that error is a back propagation that comes from output towards the input. It first updates the weights of the last layer, then last to previous layer, until it comes to the first layer. And after the weights are updated, again the input is given, the same process is repeated, and during the training phase, the mean square error progressively falls from a higher value to the lowest possible value. And that curve which obtains during the training time, showing the relation between the of the error in the output and the number of iterations in the input are called training characteristics, or they are called the learning characteristics. Yes, and once you obtain the learning characteristics, the model is ready. The same thing is applicable in case of deep learning, but the first hundreds of layers are dedicated for feature extraction. The backpropagation takes place where they take place in the last couple of layers. The verification phase, during prediction, or during other types of detection operation. So this is essentially the training mechanism of deep learning. Now, I think those who have operated, has been taught, have used or done some project or published paper that the weights are updated. The parameters of the models are updated during training phase using the derivative of the cost function. The cost function, the mean square error computed at the output. How to compute mean square error? Two things. Desired output minus the predicted output. The difference is called error. Square the error. Sum all the error square in all output node. Take the average of that. And this mean square error is called cost function. And this cost function is minimized progressively. They are to be minimized. Progressively they will be minimized. Gradient descent learning equation. Use the old weight plus alpha times the new weight, then alpha times the derivative of the cost function, then you constitute old weight. Okay, this learning characteristic is a common, fundamental. So you have to find out the derivative. Find out the derivative of the cost function by calculus method, which is very, very important. And these are available for all types of technique, particularly for RNN, particularly for radial basis function, particularly for deep learning. This you cannot avoid. So gradient descent learning today is very, very important. Now, this is a simple example. You have got the weight vector, you have got the input vector, you have to do the matrix operation, then add the bias values, you get the desired, and once you get the output passes to the next layer. In this way, every neuron functions simultaneously in a parallel manner to produce the final desired output. Okay. One thing, yeah, activation function. One thing, the effect of the activation function. The activation function, I'm telling you, in deep learning, usually the sigmoid function or you are using 10 hyperrelief function. These functions are essentially non-linear functions. These functions are chosen in such a way they are continuously derivable. That is, the derivative exists. The derivative exists because the derivative should not be an infinite value. So it is continuously derivable function, and that non-linearity associated in this activation function helps to classify, helps to predict in a non-linear manner. See, there are 3 diagrams. We must have to observe that in the first diagram, there are 3 hidden neurons. In the architecture, the number of neurons I have kept is 3. And the partition, it is a 2-class problem. One is green, number of dots are there, that is green in nature, and the separate cross, I think it is cross, are there in the red color. And the partition between the partition is linear because the number of hidden neurons are less. If you increase the number of hidden neurons and train the model and you test it, you see the partition between the green and the red, there are some non-linear phenomena has occurred. There are 2 peaks have occurred, and the partition is better, classification is better, that is tolerable. But if you increase blindly, some people increase blindly to 20 hidden neurons. Yes, we did it. The classification accuracy become more, means class 1 and class 2. There is a complete clear-cut differentiation. But this happens during training phase. But during testing phase, it doesn't happen. And therefore, this problem is called overfitting. Am I clear? Overfitting problem comes if you are putting number of hidden units more. During training phase, you are happy because the mean square error is fallen. But during testing phase, the sum element from one class being very close to the boundary jump to the other class. So accuracy falls down. So basically, overfitting is to be avoided of optimally select number of, I don't know how able to follow this concept. This is what I talk of sigmoid function. That sigmoid function which is used in artificial neural network also. It lies between 0 to 1. It lies between 0 to 1. 0 to 1. If any data become more than 1, if any data become more than 1, it is bounded to 1. This is called saturation. But within 0 to 1, the relation between the input to output is non-linear. Since most of our real-life problems are non-linear, sigmoid function works better. The other types of non-linear function, this function people are selecting because this is continuously derivable. Continuously derivable. No discontinuity is observed if you take a differentiation of this function. The second one is called activation function is 10 hyperbole. This lies between -1 to +1. The other one lies between 0 to 1, but this one lies between -1 to +1. So 10 hyperbolic function is also used if the input data is having both positive and negative. But if the input data is only positive, you have to go for sigmoid function. 10 hyperbolic is to be chosen if the data is both positive as well as negative. I was telling about the overfitting problem that we encounter in deep learning. Yes, one thing, the partition between the two classes in the first diagram is not adequate. That is, number of hidden units that you have taken is not good. Less number of hidden units. Because some circle from one side is going to and some cross to the other side. So there is jump upside. So the classification accuracy becomes less. But go to the second diagram. Second diagram is a good compromise between underfitting and overfitting. That is, maximum number of class accuracy can be achieved. That is, the circle remains, small circle remains on the process remain in the upper side. Few are on the boundary. It is very optimum. But if you still increase the number of hidden units, like last time we saw, last slide, about 20, then what you observe? You observe, yes, that some of the class, it is training-wise very good. Accuracy will get very good because each circle which belongs to one class, they remain in one side, all cross remain in the other side. But during testing time, when an unknown set of data is obtained, then you can find what? You can find that the cross jumps to the circle side, circle jumps to the cross side, and that is called overfitting. Therefore, if you look to the diagram, that during training phase, The error is very good. We are very happy. The error is falling to almost minimum value. But during the testing phase, you see the error is increasing. This happens if the number of hidden neurons is more, and the third diagram. This situation is called, we try to reduce. There is no formula, there is no research paper which says how to choose the number of, what? The number of, optimum number of hidden neurons, optimum number of hidden layers on which more research work are needed to find out the solution. Now, another thing in deep learning, one has to learn dropout. If this technique you can observe is not good during test, in the case of training, that overfitting has, and to control the overfitting, what you have to do? Regularization, dropout. That the first diagram, please see, the first diagram is completely interconnected system. But the completely interconnected system gives rise to overfitting. And to reduce the effect of overfitting, the second diagram has been designed, where you can see many of the connecting paths are disconnected. Many of the neurons are not connected. This is done with a particular probability, let us say 20% probability. This time you drop 50% neurons in each layer, 20% neurons in each layer, and the corresponding connecting weight you disconnect. Do not update the weights. Next time, next iteration, you drop another 20% of the neurons and the corresponding weight. You follow that phenomena is called dropout. And this random dropout mechanism has been shown that they reduce the overfitting problem. The overfitting problem are minimized. You can't completely eliminate because of dropout. Dropout means some of the weights and some of the neurons has to be randomly selected to reduce it. Am I clear? Now, another thing, there is a phenomena called early stopping. Use validation error to decide whether to stop training or not. Do not see the training error. Yes, see the validation error to know whether the training to be continued or the training is to be stopped. Validation error. Stopping without knowing you should not do this. There are many types of performance measures. One type of performance measures is loss function. Loss function is defined at the first box, the bottom one, loss function. There are two classes. So yk log yk plus 1 minus yk log 1 minus yk. So this is called what? Loss function. This is also defined as cross entropy. Cross entropy is a measure of quality of training. Instead of mean square error, in case of regression, we use mean square error, and we can use mean absolute error. But in case of classification, we use cross entropy. Another thing, we use sigmoid function or linear function, ReLU function, in case of regression. But we use softmax function, softmax, softmax function in the output layer of classification. This had to be borne in mind. So basically, I give the types of thing that is done in case of artificial deep learning model. You come across overfitting, you come across underfitting. To avoid that, you have to use dropouts, random dropouts of weights and the connecting weight. And to measure the performance of a deep learning model, what you have to do, deep learning model to drop out, we have to employ, yes, loss function. The performance measure, you have to epoch on the x-axis and epoch on the x-axis and y-axis loss function. And in the classification problem, output side, you are using soft. Whereas in case of regression, you are using sigmoid function or ReLU function. But the performance measure is called mean square error. Actual output minus the desired output, square them, add them, and then you use sum of the square error, and that is used as the performance measure. Also, some people use the magnitude of the error, not that is the value of the error, not positive and negative. They do not take, they take the absolute value of the error. Now, I'll give a gap of 2 minutes, and then this deep learning is not over. I'll give a simple example of CNN and go detail about it. So there is another slide for CNN, but here I am giving some of the small example. So speak on this for 10, 15 minutes, and then I'll go for the deeper of the convolution neural network. Please wait for 2 minutes.
Okay, sir. Okay, sir. Sure, sure. Participants, please take a break for 2 minutes. Sir will continue the lecture after 2 minutes. Meanwhile, you can push your messages related to of your project or here in the chat window or directly to me or in the WhatsApp group so that I can bring forward to sir. He will address all those problems in the immediate to the session, either today or tomorrow. So I request everybody to type your queries related to your projects and forward them to us.
No sentido. Tu produce un reglamento automático para la autora because mother said let us see your future. Porque te manda por el día. Todo de hecho. Participare di programma per si capire la tecnica. Salvo per applicare il futuro. Noi ci capiremo. Non cresce. Non è volere. Hello?
Yes, sir.
Yes, we'll start.
Yes, sir. Yes, sir. We'll start, sir.
Yeah. Let's see.
Yeah. Everybody was yes.
Uh, let's see here. I'll give a simple example. The fundamental of convolution neural network. It has become very, very popular today. And if people want what are the different applications, I can tell for hours. Today, I ask the question to most of my researchers, why convolution neural network we know, but why convolution neural network is so important? CNN. Convolution we read in signal processing. There are two types of convolution, circular as well as linear. Now this convolution is nothing but software method of filtering. It is the software method of basic. That software method of filtering is eliminate the noise, the unwanted thing, and try to preserve the required thing. So one round of convolution is a method of filtering unwanted information you are trying to remove. In the second case, once again if you perform convolution, again unwanted information is removed. First you do, finally we want refined features. Finally we want precise feature. So initial stage of convolution, feature. Again if you do convolution, we get still better refined feature. So number of stages of convolution make the features precise, make the feature accurate. Therefore, the prediction become better. Therefore, the classification become better. Please remember that convolution neural network performs convolution, two-dimensional convolution. Two-dimensional convolution is performed because of it is a two-dimensional because mostly you are seeing a first green input matrix, and you can see this matrix that it is a size of 5 into 5. Size of 5 is 5 into 5. 25 elements are a convolution filter. The coefficient of the initially the convolution filter is random value 1, 0. But how to perform the convolution? Diagram. The convolution filter is put over the image. So you take an image size of 3 by 3, take image size of 3 by 3 and convolve with the filter coefficient of size 3 by 3. Interestingly, that both are overlapping, size are same, the corresponding points are multiplied. That is 1 is multiplied with 1 is multiplied with 0, and 1 is multiplied with 1. So in this multiplication, then what we do? We add them. After multiplication, we add them. And after addition, the answer becomes 4. Because there are 4, 1 and 4, 1, they are added. So the first convolution output that we obtained from the convolution process is equal to 4. And this process we repeat. What to do? What the meaning of repetition? That is basically, after the convolution, I obtained this 4 by 4, and they are called the features. These features we obtained by sliding the window. That is, in the next case, we just see here, we do for first point, now we shift it. Which one we shift? The filter is shift by one position towards the right. And again 3 by 3 pixel values are convolved with what? Convolved with the filter. Again we produce one output. Again we shift towards the right by one position. In this way, from left to right extreme, we cover it. And this coverage is brought down. That is, the same filter is brought down to one step down. And by By doing this, with the dimension is reduced and 6 by 6 filter become a size of 4 by 4 after the convolution operation. You see, it become 4 by 4. And after this 4 by 4, this you call the first raw features. So convolution operation produces raw feature. But if you do number of convolutions one by one, then the number of features are more become precise, the dimension is reduced, and you get better feature for prediction or classification. The another thing which is used is pooling. Pooling is for dimension reduction. So how the pooling is done? This 4 by 4 site, which is obtained after one stage of convolution. You see, one stage of convolution, 4 by 4, we are obtaining, and maximum pooling is brought into 4 different parts. Each part, the first part is 6, 4, 5, 4. And this first quadrant of this image, after convolution, what we do? We basically, we take one value out of this. That is the maximum of this. As you see, in this first quadrant, the maximum value is 6. So maximum pooling produces 6 output from the first diagram. And then again, we do for the second quadrant. And the maximum value is 8. Third quadrant, the maximum value is 9. Fourth quadrant, the maximum value is 7. In this way, we produce the pooling output. I'll tell the purpose of pooling later on. So basically, CNN is used for a lot of hundreds of applications of data, whether it is a historical item, whether it is a story, whether it is a political item, this can be found by CNN. So text automatically classifies by extracting the right feature by stages of operation. Therefore, today, CNN is a potential application in many types of work. I told you that we use only one filter, but in actual practice, we use many filters. That is one filter, because the filters, so better quality of one set of filter feature. If you are taking second types of filter, more better features are extracted. Use different types of feature extractor, and these feature extractor are nothing but filter, and these filters are adapted by adaptive algorithm, by back propagation learning. The filters are updated. The filters are updated to obtain the right kind of feature, to obtain proper classification, proper forecasting, or proper detection purpose. So this is what the purpose of the, now we can find the recurrent neural network. Recurrent neural network. The recurrent neural network is another type of, I'm just giving an overview. The recurrent neural network is another type of deep learning. The recurrent neural network, as I told yesterday, takes the feedback. Therefore, by taking the feedback, the performance is improved. Okay, so more deeper of the recurrent neural network, maybe time permits, and basically the recurrent neural network is, and your LSTM is an example of recurrent neural network. LSTM is a type of, and recurrent neural network is just like I told yesterday, that like an IR filter. So there is a feedback from the output to the input, and therefore you get what? You get some memory of the past data. So performance of the prediction or classification much better. So this is very, very important for you to learn more about the recurrent neural network. A recurrent neural network is a very interesting architecture, and the recurrent neural network can be bidirectional, can be unidirectional, can be both. in case of bidirectional, it is very symmetrical and it learns faster. So basically what I'm trying to say, that people should use bidirectional RNN. Bidirectional RNN is just like IR filter with less number of sites, the performance can be obtained. But in this particular RNN, one problem that we encounter, you must know, and these are called what? These are called vanishing gradient. Vanishing gradient is a sometimes what happens, that basically when you learn that many stages of iteration, then basically you can find that the derivative becomes 0 and 0. So once the derivative becomes 0, then what happens, you cannot able to update the weights. You cannot able to update the weights. Therefore, one has to be very careful to overcome the vanishing and to gradient problem. LSTM has come. LSTM try to remove the vanishing gradient, that is, the weights are not updated. Weights are frozen, and therefore these are very, very powerful algorithm. And I feel that those who are starting research or starting work, project work, must use LSTM, long short-term memory. These types of network are deep learner, and they are very interesting, and you can use for healthcare problem, for finance problem, for various types of applications. And your antenna problem you can use. You can use in IoT, in security, in healthcare. So these are the things we must try and must learn. And therefore, this I want to tell about the another types of deep learning. Another types is decoder encoder. Decoder encoder is very, very interesting. That is, if you look to, it is used as a compressor. Whatever the input you are getting the same output. Then what is the advantage? That in the hidden layer, you are putting less number of what? Less number of nodes. And because of less number of nodes, what you are trying to do, that because of less number of nodes, the data is feature. So for feature encoder decoder model is today, encoder decoder is a type of deep learner for powerful feature, for classification and for all. Therefore, if you want more details, I want to tell on this encoder decoder model. Yesterday also I was telling about gated recurrent unit, GRU. Gated recurrent unit is another type of feedback mechanism. It is similar to RNN, a particular case of RNN, but in this case you have some memory element, and I think the performance of GRU is better than the conventional your RNN model. So people use either LSTM or GRU, and they make a combination of these two to achieve better performance. I feel you must learn more about GRU and LSTM for your research and R&D work. And they have a lot of potential application, and they are just like your IR system. So a lot of application example. People are throughout the world are using the GRU model. GRU model are used for language processing. They are used for speech recognition, speech enhancement. Google is used these types of deep learning model for various of their application. I think we must learn the new technology to achieve these types of problem. So basically, classification problem and forecasting problems are better used. Classification and forecasting problems are used today using this GRU as well as these types of RNN mechanism. Can I give a gap for a couple of minutes?
Yes, sir.
Yeah,
yes, sir. Yes, sir.
2 minutes.
Yeah, no problem, sir. Srikar, Srikar, are you there? See, I suggest all the students of third year and final year, they can come out with a project proposal which they want to pursue under the guidance of Panda sir. See, he will be in continuous under this, so he can guide you very good project, and finally which that project outcomes for publishing also. Okay, so I request everybody strictly follow this and come out with your project proposals. That project outcomes for publishing. Yes, Vikar, and the remaining people also. You can drop a message if you have any. At the end of the session, sir will be dealing with them. So if you have any queries, any questions on the topics dealt today or anything related to your project or proposal, you can drop a message in the chat window. I'll read out for you so that for sir to look into that and answer and help you out. Yeah, Shrikar, you can do that.
Hello?
Yes, sir.
Yeah, I went
Yes,
to
sir.
bathroom. Yes. Okay.
We are
Okay. Okay. So basically,
yes,
no.
sir.
Yeah. The MLP, the conventional MLP, also can be used as deep learner, provided the number of, yes, provided the number of more. So MLP used as a deep learner. The model of a NN, that use sigmoid function, pooling, then you use convolution layer, then you convert the 2 dimension to 1 dimension, and then use classification and other purpose. The bidirectional GRU is also a model which is very, very important. So basically, I'm giving a set of reference. And this slide, if you want, Chakravarti, I can share you. So people can see and find more references to know more detail. Now I'll load for, after a minute, I'll go a little deeper into the CNN. Yes? Hello? Hello?
Yes, sir.
Yes. So I'll load the other slide. Another slide is there, and which I'll discuss for about 40 minutes.
Yes, sir.
Okay. Just 1 minute, please.
Yeah. Sir,
Just 1 second.
I
Sir.
have
Power has come.
yes.
Just 1 minute. Wait, just
And
I'm switching on UPS. Please have patience for a minute. Yeah, just a minute, please. Slide. CNN. 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 সেটি আছে না থাকে লাইট সিএনএনটা সেটি আছে না এটি আছে সিএনএনটা সেটি আছে না এটা পুরোটা Is it visible? Full form.
No, sir.
No.
No, sir.
Not visible?
Not visible, sir.
Okay, just a minute. Is it visible?
Yes, sir. Now it is visible.
Right. Is it visible?
Yes, sir.
Okay.
The first slide is visible.
Please see. This CNN I have already told it. Because this is very fundamental, deep learning method. So I'm on this.
Okay, sir.
This is a CNN architecture. The number of layers I have shown 3, but in practice there will be hundreds of layers.
The slide
Purpose of
is
each of the initial layers for feature extraction, as I have told. Input, when the amount of data is large, you have to use
sir,
deep learning
first
like
slide.
CNN.
Sorry to disturb you.
Yes.
Excuse me, sir. Sir, I think we are still with the first. You not share the entire. Yes, ma'am.
Tell.
You the entire screen. I think only the application is shared.
Application.
Yeah. Because I think you are going in the presentation mode. The presentation mode screen has not been shared.
Okay.
Yeah. You have to actually share the entire screen. Screen number 1 something will when you are asked to do so. Yeah.
Visible.
Yes. Exactly. Is the Explorer we are seeing Windows Explorer.
Visible. Entire screen.
Windows Explorer is visible, ma'am. Open the PPT. Have you opened the PPT, ma'am? No, you selected the screen number 1. Yes, ma'am. Are you there? Hello.
Hello.
Yes, sir.
Just a minute. Is it visible?
Sir, it is not in presentation mode, sir. Continue like this.
That is not visible.
The first slide is visible.
Huh?
First slide is visible.
Is it visible?
Yes, sir. First slide is visible. Can you go to the next slide?
Subsequent is not visible. This one. This is visible. Make it bigger. Okay. This is visible?
Yeah. Yes, sir.
Okay. This
Yes,
size
sir.
or should I enlarge?
Yes, sir. If you can enlarge.
So this size I should continue? Okay. So this is, hello?
Yes, sir.
Yeah. Okay. So this again, I'm talking about the same slides which I talked yesterday. So basically, why you use a sliding window to run from left to right, then from top to bottom, cover the whole of the data, that is the image, because if there are some minute features or pattern that can be detected. For example, the big detector model CNN can be used. That means we are making such a filter that filter will detect anywhere inside the picture if a beak is there. Now this can be done with the help of a convolution neural network. As I told, you can see the beak is here. Is it visible or not? Hello?
It is visible, sir. It is visible.
Okay. Now you see this in the top diagram. The bird is there. The beak is on the left-hand corner. So it is a upper left beak detector. When the moving window, the red one, filter is moved from left to right and top to bottom, when it comes to the, you see another, so the beak is in the center, a middle beak detector. That is the reason we move right and from top to bottom window. And each time that filter window, we do the convolution with the picture window and we move. The training period, that small detector of a small interested pattern can be detected or classified. That is the beauty of it. Basically, if you look to this diagram, convolution layer, as I told, that you are designing a filter which you call a big detector, and you are giving the input image, and you are able to get the. So big detector is nothing but a filter, and this convolution operation performs that filtering, and that filter coefficients are adjusted. Again, it is not a fixed coefficient, it is an adaptable filter, and the parameter of the filters are adjusted by backpropagation learning. Okay. Now look to this one. If you look to the convolution, again I am telling that this is a 6 by 6 image, and I have taken two filters. First I am explaining with filter 1. So this 3 by 3 filter is put in the initial part of the picture, and then we perform the convolution. And then this will proceed from left to right. For example, if you look to this filter 1, I put, you see, the first red one is nothing but the picture values, and the right side top corner is the filter coefficient value. And the corresponding points are multiplied and added to produce the first output 3. 3 is equal to 1 into 1 plus 0 into minus 1 plus 0 into minus 1, second row 0 into minus 1, 1 into 1, 0 into, and like that the multiplication, and all 9 products are added to produce 3. Now I shift from left to right by 1 column, and that is we call stride 1. Stride 1 means shifting the same moving window towards the right by 1 column position. And then this new pixel value of 3 by 3 is again multiplied with the corresponding filter value. And then 9 values are added to produce an answer of minus 1. Again it is shifted towards the left. So like first column to last columns are covered. Then we are moving from top to bottom. This process of covering the full image is known as the convolution operation. Here stride equal to 1 because you are shifting from left to right by one position, left to right by one position. And this can be done by this can be shifted for more position. So basically, if you look to the second one, I got -3. Now this can be changed. Yes. So this I obtained the -3, and you see here, like that I can change from left to right, from top to bottom, and I get a size of 4 by 4. How actually I obtained? For stride equal to 1. Stride means how much shifting you are doing at a time. Here I am doing 1 column shift. It can be 2 column shift. It can be 3 column. Then in that case, stride will be 2 or stride will be 3. Now the size was 6 by 6, but after it has reduced to, that is the number of picture size is m, the number of window size is n. Therefore, after first round of convolution, that is the feature extraction, the number of the size of the feature become n minus m plus 1, 6 minus 3 plus 1, that is 4 by 4. So not only you get feature reduction, you get a dimension reduction, also you get a raw feature. Again convert with filter. Process continues and the dimension reduce. So this is what types of operation that take the first few layers of CNN network. Similar operation we do for filter 2, because filter 1 has a job of big detection. Filter 2 may be a job for detection of feet or tail. Depending upon the requirement, you take an initial filter coefficient and perform the convolution such that the convolve output represent the feature related to the target object. And this operation continues. So this is, you are doing with a stride of 1 convolution of the original image with not filter 1 but with filter 2. You get this one. So this process continues, that goes on the other. Okay. Now you see next one. Please see. If there are a colored image, then there are RYB colored image, and you are seeing there are many sets of filter. Yes, filter 1 for each color, same filter 1 is used. After one stage of operation, then all 3 channels they use filter 2. So filter 1, 3 channel, and each channel use filter 1 in the beginning. After that they use filter 2. After that they may use filter 3. For each filter operation, they get 1 output. Yes. And for second filter operation, they get again another. And since there are 3 colors, there are one matrix you are seeing for blue color. Below that you are seeing for green color, and below that you are seeing for red color. Now convolution versus fully connected. Convolution convert an image into 2 dimensions. As you are seeing, the image after convolution, you get a reduction in dimension, and for each color you get a featured output. Now this feature output, if it is fully connected, that is your 4 by 4. If the original picture is 6 by 6, original picture fully connected, so x1 to x36, 6 into 6. So 36 input of the picture we are getting, and they are passed to produce 4 by 4, 16 output. And that is nothing but multiplication and addition. Each time we choose the right kind of fully connected in neural network, which all are connected, all input is connected to the output. But in case of CNN, you see, All see here in the first case, 1, 2, 3, 7, 8, 9, 8, 9, 10, 11, 14, 15, 16. So the number of their position has been written here. And this 100, that is 1, 2, 3 values are connected to produce 3. Similarly, 8, 9, 10, second row, third row, 14, 15, 16. All the 9 values are connected, yes, with the filter coefficients, these filter coefficients, and they are produced to output the 3. Similarly, to produce the second output, similarly selected, second output means slide is 1, you have to shift 1. And the new position are interconnected to produce the output -1. This process goes on. So basically, this is the operation, mathematical operation that takes place inside the CNF. Okay. Now basically after this, you can see here, this operation we perform. I have not talked about pulling. Basically you perform convolution. Again another filter convolution. Again another filter of convolution. And then subsequently you do flattening. Between you do pulling. Maximum pulling from each of the quadrant, I pick up the highest value. That is first 4 value, I take the highest value. Second 4 values, I take the highest value, and so on. So out of 6 by 6 picture have been reduced to 4 by 4 after convolution. And after pulling, you get only 4 values, 1 from each quadrant, which is the highest value. And this operation similar for filter 2. So basically a 6 by 6 picture has reduced to 2 by 2. Yes, that is, you have got only 4 values out of 36 values. That is how there is a lot of dimensionality reduction. Yes, let us come to the fundamental of pulling. I ask everybody, why pulling is done? Pulling is nothing but subsampling. Out of 4 values, you are choosing 1 value. Every 4 values from each quadrant, you are taking the highest value. That is it. If you make a plot, this is the picture, original picture, and after sampling or subsampling, you get a smaller picture. You see, the quality of the bird remains same, but there is a dimensionality reduction, and that is called subsampling. We are not reducing the quality. The characteristics of the image remains, but the dimension becomes less. And obviously that becomes the features. Yes, this is the purpose of pulling. You take the highest and in maximum pulling. In case of average pulling, you take what? You take the average of the previous 4 values. That is, if you take the average of the previous 4 values, 3 minus 1 plus 1 minus 3, you take the average of each one. You get again 4 values, but that is average value. Next one. What is CNN compresses a fully connected network in 2 ways. Reducing the, as I told, shared weights on the edges. Maximum pulling further reduces the complexity, because from the quadrant you choose only 1 value. So basically, I took a picture of 6 by 6, performed convolution with a filter, and after that I did the pulling, and finally I obtained this answer. This is for 1 stage. Imagine what will happen for 100 stages. The input size of image is 300 by 300 picture. Finally it will reduce to some 10 by 10 or 8 by 8 picture size by convolving with the filter. Each filter has a characteristics. Some filter extract Raw feature, some filter extract refined feature, some filter extract very, very refined, precise feature. Now the filter coefficient in the beginning are random, but subsequently the filter coefficients are updated to sharpen, to find the precise feature, the good features out of the raw image. Thing I told, after the pooling operation, dimension is reduced. The first one is for first color, second one is for second color, and so on. And they are flattened. And sometimes for each of the filter, the first one is for first filter, the below one is for the second filter. They are put from 2 dimension to 1 dimension. Now it is called flattening operation. Conversion from 2 dimension to 1 dimension is flattening. And this flattening operation then connected last few layers as a classifier or predictor, just like our neural network, but the number of layers more than 3 or 4. So the flattening operation, conversion from 2 dimension to 1 dimension to pass through a filter. These input values are called the features. So until now, that is the convolution followed by pooling, and then again convolution by pooling does the feature extraction of the raw data. And these features are passed through this network to produce the desired classification output. So this is very, very fundamental to this. Okay. Now if you see the whole CNN, please have a look, the whole CNN. So the whole CNN, take a picture, perform the convolution with a filter coefficient, then perform pooling. Again another stage of convolution with another filter, again pooling, and go on doing until you get a 2-dimensional data or feature. How many layers to be taken depends on the types of problem, depends on the type of feature. You see, the accuracy of classification or the accuracy of prediction is not good. You increase number of convolution layer. If the performance is remaining constant, do not use more convolution layer. So it is a trial and error method. There is no fundamental principle on the basis of which you can able to decide the number of convolution and pooling operation. Finally, the whole CNN, I have shown you many times, but for understanding I am making it again, that the whole CNN therefore looks like this. Fundamental one is convolution, pooling, and finally flattening, and after flattening, classification or forecasting by conventional neural network. So this is what the outline of the talk I gave on deep learning and CNN. I just gave an overview of what is overfitting, how to remove overfitting, what is dropout. Then I talked what is pooling. I talked about 2 types of pooling, maximum and average pooling. Then I talked about flattening. Then I talked different types of filter for different types of extraction of features. And final couple of layers, either for prediction, it is a fully connected network, either for prediction or for classification. Dropout of the neurons are done to reduce overfitting. Number of hidden layers are optimally chosen to reduce overfitting. Overfitting problem performs well during training, but testing or validation performance become poor. So we should not overfit a model. These are the various, some of the issues we must remember in case of deep learning. Professor Chakravarti? Yes?
Yes, sir.
Yeah.
Yes,
so next, there are about 12 to 14 minutes. So if anybody asks any question, I'll try to answer and clarify. Is it okay?
Yes, sir. It's okay, sir. Sir, I have sent a message to you on WhatsApp regarding a question from one of my students.
Hello.
Yes, ma'am. I have sent a WhatsApp message to sir regarding one of my students' query, like a project idea, and he wished to detect the number plate of the vehicle.
Okay, I'm just telling to sir. Sir, send message quotation WhatsApp रे. ତାଙ୍କ ପିଲାର WhatsApp message. ତାଙ୍କ ପିଲାର query ଅଛି. Sir, in which number you have sent? Okay, okay, sir. Number plate of vehicle.
Reading the question, yes, from Sekar. Give me half a minute time. I'm just reading out his question. I'll answer. Okay?
Yes, sir.
Yeah, I have a project idea. Good. What is the problem? Which is to detect the number of plate of the vehicles and report it with timestamp. Number of plate of the vehicles. This can be used to check the attendance of the arrived college buses to detect the vehicles. Okay. Attendance of the arrived college buses to detect the unknown vehicle entering into the college. However, I'm a little confused. I do not know how to start it, sir. I need your guidance. Very. Hello. Hello.
Yes, sir. Yes, sir.
Can I answer?
Yes, sir. Yes, sir. Please.
Yes, yes. So, have you implemented what technique you have used? It is first you have to take the image of the plate. Yes. And then you have to do identification of the image. You have to extract the number plate and the name of the writing of the plate. And if you store from your own institution, you have got a set of number of buses. Everything you pre-stored, you know the desired signal. If the plate differs, if the number differs, then the gatekeeper should not allow. Hello? If one is registered, so that is a simple logic. It does not require deep learning. It requires machine learning. It is a classification problem, whether the bus belongs to or the car belongs to Raghu Institute or not. So all the registered number has to be registered. As soon as the nameplate is written, comes to the gate automatically that picture should pass through the classifier. It is a simple neural network SVM classifier. You can use that eccentric classifier. If you have got the data, collected the picture data of all the nameplates, then and store everything, I think you can come and discuss with me. I think in a couple of days you can develop an app. An application software can be developed. Is it okay? It doesn't require deep learning, but certainly you can use other types of classifier, machine learning classifier. Is it okay?
Yes, sir. Yes, sir. He is listening, sir. So
you
I
write
think.
Your question. Little do not know where to start it. We need your guidance. You start, I will help. We can separately discuss. First thing you have to get the picture of the number plate of all the registered vehicles which are permitted to come.
Yes, sir.
Which are the desired signals. So it is supervised learning.
So I think I can ask him to prepare a document on it.
This can be done very easily, provided you have the desired signal first. Then as soon as a picture, you should put a camera. As soon as the photograph of the nameplate is taken, that information should come, and that information should use for a train model. Already you are training for all the registered vehicle. If the vehicle, as soon as a new number comes, it will check whether belong to class 1 or class 0. If it is matching, then it should permit the gatekeeper to open. The vehicle will be kept outside.
Yeah.
Pattern should go. Gatekeeper will immediately park them outside.
Yes, sir. So what kind of a features you used, sir, to extract from the...
See, from the picture, you have to calculate a running window. As I told, you can perform convolution. You can take statistical feature. You have to take Fourier transform or wavelet transform of the picture. Wavelet coefficient, yes. You can calculate. Use this coefficient. It is a numeral and recognition. Hello, it is a character and numeral. Am I correct? They may be written in English or Telugu or Hindi. So you have to have.
Yes, sir.
Yeah, you discuss. You have to discuss. I can help you to. It is not a difficult problem, but you need discussion to achieve it.
I will ask him to prepare a document on this. Tomorrow, if possible. Tomorrow, if possible, he will.
Any other question, please?
Yeah.
That's a Chakravarti you send me.
Yeah. Yes, sir. No more questions, sir. Yes. There are no more questions.
No more, sir.
Yes,
hey, Professor Chakravarti. Hello, Professor Chakravarti.
Yes, sir.
Okay, thank you then.
Tomorrow, they will...
Tomorrow, it's spiking neural network. Is it okay? Okay.
Yes,
tomorrow
sir.
They will come with their ideas, project idea. Okay. Thank you. Sure.
So we'll spend half an hour on that, sir. Tomorrow we'll discuss this spiking neurons, and then we'll quickly move to some discussion on these projects. Yeah. Okay, sir. Thank you, sir. Thank you. Sir, thank you very much, sir.
Yes. Okay. Thank you then.
Thank you very much, sir. Tomorrow we'll spend some time on. Thank you for your valuable contribution and valuable time, sir.
Thank you.
So
thank you.
Tomorrow we'll get back to you, sir, once again.
Okay.
We take help in regarding some good projects as well as some research problems also. As soon as we complete the lecture, we'll discuss on it, sir. So
okay.
Meanwhile, I'll use that I can get the documents and send it to you.
Okay. Thank you.
Thank you. Thank you, sir. Thank you. For permission, I will end the meeting, sir.
Okay, sir. Thank you. Please end the meeting.
Yeah. Thank you, all the participants, my faculty members, my colleagues, and all the HOD here. Thank you very much. Once again, thanks to Ganapati Panda, sir, and the one who is with sir. Thank you very much, ma'am. And also to our HOD and Vice Principal, Professor Satish Ram Chaudhary Garu. Thank you, everybody. Let's take a break. You can project ideas and send so that I can inform the same to Panda, sir. He will spend some time on your project ideas, and some valuable outcome will be definitely possible. Okay, so it will be definitely going to help you out in completing a very good project at the end of the third year itself, which may be even to your final year also. So thank you very much. If there is any session, you will be informed on WhatsApp. So for the time being, you have a lunch break. Bye everybody. Yeah, Srikar, you too. You please concentrate on preparing a document on it. A one-page graphical or simple diagrammatic representation of your problem is sufficient. Okay? Bye-bye.